I guess that's enough of that. Hello, good morning, afternoon, evening, bonjour, buenas noches. Thank you for joining us at Outlier today. I hope everyone's been having a great time with all the other sessions so far. If you're here, you must be either interested in sports, historical data visualization, or you were confused by the name of my talk just enough to be curious, but not so confused as to be turned off completely. And for that, I thank you. Over the next 20 or so minutes, we're going to dive into some of the most profound works of historical data visualization and infographics, and then we're going to take all that profundity, ball it up, and shoot it through a basketball hoop. Maybe this is why people still hold on to that line from Jurassic Park, the one about the scientists being too preoccupied with whether they could before they stopped to ask whether they should. Anyway, only one way to find out, right? Hey, I'm Senthil. Thanks so much for joining me again today. I graduated from Rice University in 2017 with a degree in electrical engineering. That's my junior project there, but even if I told you what happened to it at the end of the class, you wouldn't believe me. As you could probably imagine from looking at that, I wasn't really into electronics and electrical engineering. I wouldn't say I naturally had an affinity towards it. I prefer to spend most of my time fiddling with data instead. That's why I actually graduated with a specialization in data science. And so that's what I do. These days, whether it's my day job, afternoon job, evening job, night job, right? I spend all of my time doing data analytics, sports, finance, etc., you name it. Of course, we've been working from home for the last year or so, and I discovered in quarantine that I actually really like to cook. That's a tres leches cake that I made for my dad's birthday last year. Not just cooking, I love sports. That's a picture of me and my roommate at Yao Ming's jersey retirement game with the Houston Rockets back in my senior year. That's me with pink hair at my office holiday Christmas party right before COVID started. But hey, like I said, I love sports, right? So maybe when COVID blows over, y'all can join me for a round of tennis sometime. But anyways, before we get too far off topic, that's not what we're here for today. We're going to go back to sports. Specifically, we're here to talk about cool data projects related to sports. See, I've had a somewhat unconventional data visualization journey. And I don't mean that I was shamefully still using Excel default 3D graphs in high school. If you say you didn't do that, you're a liar. I don't have classical coding training. I didn't study design and information graphics. Like I said, I was an electrical engineer who preferred to spend most of his time fiddling with data instead. My data science and analytics journey has been primarily self-taught. And a lot of that inspiration for self-tutelage actually comes from wanting to dive into specific sports analytics questions and poring over historical work. And so there I was one day, I was trying to learn a little bit more about the Bokeh Python package for data visualization, and one of their examples in their gallery is actually this recreation of Burton's infamous antibiotic resistance graph. Of course, I wasn't necessarily into antibiotic resistance at that time. Sidebar, maybe I should have been. It would have served me kind of well right about now. But that said, I, like I mentioned, prefer to answer sports questions, prefer to deal with sports data. So what I did was, in order to learn how to use this package and learn how to recreate this, I took the example code for Burton's antibiotic resistance, and I turned it into something slightly different. See, the NBA playoffs were actually starting at that time, so I used it instead as a means of mapping out the talent level on the teams that made the playoffs and splitting it by Eastern versus Western Conference. I posted this online and it kind of took off. It was kind of popular. It wasn't your regular bar graphs and line graphs, and let me tell you right now, bar graphs and line graphs are in for a heck of a ride over the remainder of this session. I thought this was pretty cool. It was this just really funky, unique graphic that still delivered an impact through its sunburst form and told a clear story. And other people agreed, and so from that standpoint on, I just couldn't get enough of historical data visualization. I didn't want to stop with, just recreating something from an example gallery, from an example package. I wanted to see how much I could learn from historical data visualization and leveraging it towards the data sets and towards the visualization of information that I was truly curious about, towards the analysis in sports that I actually really cared about. What could I learn from history's best data viz practitioners. So I went to Florence Nightingale. This turned into an expose on LeBron James playoff runs. Then I went to this theater receipts from the Universal Exposition in France. This turned into something that I could only think of as fitting considering the theatrical nature, and that was Michael Jordan's scoring outputs. All of these works have something in common, other than the fact that they don't have a lot in common, is that they're unique renditions of data visualization that push the boundary of what data viz means and what data viz can be. In many ways, on this axis, it's something a little closer to data art, right? This is a bit of an oversimplification, but it's not the kind of data visualization that you encounter on a day-to-day corporate basis or a business intelligence quote unquote basis. It's something that moves the field forward by expanding what the possibilities of that field even are, and refusing to be defined by a strict system of rules. That's also a through line that's going to come up quite often. So how did I get started on this project? How did I work on this project? Like I mentioned, again, I don't have any formal design experience, so I wasn't actually tied to a specific tool or language. I used Pixelmator for a lot of graphic design work and post-processing. I used Python for the majority of my data analysis and code-based preparation and cleaning. I even dipped into Excel once or twice to do some exploratory data analysis. All of that was in service of this one question. Why do we look to the past? Think of this as the driving query behind this project, and one that I hope we'll be able to satisfactorily answer by the end of this session after looking at a few examples from my project. I've split this into 3 categories that we can go through, because I like to think of each of these works of historical data visualization as fitting into different types of purposes. They accomplish different types of things, and they serve different types of goals. So I've broken them up into these 3 categories that you see here. So let's go ahead and start with the idea of charting phenomena. And for this one, we're going to throw it back all the way to 1611. Please take the stage, Christoph Scheiner. This is a piece where he actually tracked the progression of sunspots over a month-long period in his correspondences with Galileo Galilei. Now, we don't need to get to the science behind Scheiner's beliefs on sunspots or the composition of the sun, but take it that it's fair to say this is one of the first examples of small multiples graphs in history. And yeah, data visualization was critical, even going all the way back to the Galileo era. Scheiner was using this as an objective proof point to document what he was observing in the stars, right? He actually did a lot of unique things here. One is this implied coordinate system. By fixing this coordinate system circumscribed within his grid, he's able to clearly standardize the positioning of the data points so that you can track within this circle where are the data points moving over time. There's this chronological progression of small multiples. You're able to compare the positions on different days against each other and see how they track from the starting point to the last diagram. And not just that, he, just like many other formidable data visualization practitioners and prominent data visualization practitioners, had a very thorough explanation of his observational methods. He wanted you to know exactly what he was doing, how he did it, how he was tracking it, and how to read his graph. You ever heard of the term moonshot? The concept of seeking out 10x solutions that have extraordinarily high barriers to overcome. Now imagine how DeAndre Jordan, professional basketball player for over a decade, feels every time he steps onto the free throw line. Over his entire career, he has made, and I actually had to fact check this, less than 50% of his free throws. Yeah, that's a very low number. Every time he goes to the line, he is throwing up literal and figurative moonshots. But hold that thought just after you burn all of those air balls on infinite loop into your eyes. Step 1. Step 2. Some of y'all may be able to see where we're going with this. Imagine if Christoph Scheiner had been around as a basketball fan in the 21st century. Instead of mapping the progressions of celestial bodies and sunspots, he may have instead decided to map DeAndre Jordan free throws. Actually, you know what? You don't have to imagine anymore. That's the beauty of this project. I took the liberty of doing it in his name. So I present to you, dear viewers, DeAndre Jordan's sampling of missed free throw attempts between the 2013 and 2016 NBA seasons, presented in chronological order, beginning with 2013, October 31st, all the way to the 22nd of January in 2016. How are we going to read this graph? Exactly as it's been documented in the top right corner. The backboard is to the right. You're pretending that DeAndre Jordan starts at point A and is shooting towards that direction. So you can notice then the way to read all these dots is his missed free throw attempts are actually really scattershot, and very few of them are actually making any kind of reasonable contact over the rim. This is, he even had one game, and it's sampled here on the 30th of November in 2015, where he had 18 points, 24 rebounds, and 22 missed free throws. A weird kind of triple-double that's, not really recorded in the history books. 22 missed free throws is an all-timer. But this isn't just some random, hilarious phenomena. It's actually an important strategic element in the NBA. These big, powerful centers who tend to play close to the rim, but are actually fairly poor shooters when you put them at the free throw line. 538 even had an article about it many years ago when DeAndre Jordan was with the Los Angeles Clippers, talking about how much opponents can optimize and find a balance between forcing DeAndre Jordan to shoot free throws versus letting the rest of the Clippers offense just pummel you to death between the trifecta of talented players that they had leading them. So it's actually not just some humor at DeAndre Jordan's expense, though admittedly, if you're a viewer, it's kind of funny as long as you're not a Clippers fan. It's actually a very important strategic development in the NBA. And now you see a lot of these NBA centers who are more multifaceted and have much better shooting strokes. So we had a lot of fun. In charting phenomena, we took that category and infused it with a lot of levity. But now we're going to move to our second category, awareness and change. And while the last one was full of levity, this one is going to be full of tough questions and introspection. And the best person I think to lead us in this direction is W.E.B. Du Bois. This is a riff on a bar chart which Du Bois used to map out and highlight the splitting demographics of locations where Black Americans were living at the time. This could have been a bar chart, but its simplicity and its creative design and its encodings really set it apart as a historical artifact. It doesn't have the complexity of many Minard pieces or the small multiples features that we just saw with Scheiner. The goal of this one is to prove to you that this is not a dataset that can be contained in a bar graph, because you are immediately drawn towards that spiral at the bottom. This aesthetically captivating spiral that is a disproportionately large anchor point. Du Bois actually really liked to use these spirals and wraparound techniques whenever he was dealing with outsized quantities that he wanted to draw your eye towards. It wasn't actually just with this piece. He knows that comparisons are intentionally rendered meaningless and useless, because people might ask, well, it's hard to tell the data from a spiral, but that's actually Du Bois' point. Comparisons are meaningless because all you need to know is that this quantity, which he has, by the way, annotated so that you do have the exact number, is so large that it's bigger than the quantity of Black Americans living in any size of city combined. That's how many folks, Black Americans, were actually living in rural America at that time. He's annotated it because he knows that intentionally the point is not comparison. And then I think the element that really brings this together and drives the point home is this almost poetic hierarchy. It's not the color here, but this idea that at the top you're starting with big cities, then medium cities, then small cities, and then finally coming down to rural America. Even the visual aesthetic here of the bars swinging back and forth emphasizes this poetic nature. And so that's what we're going to work with. We're going to use these colors, set them as a basis, and ask some tough questions about minority hiring practices in the NBA itself. So hold on to that thought. We have players, head coaches, general managers, all the way up to NBA owners. This is the proportion of each of those categories who are black. If you want to look at this in terms of exact quantities, that's right, only one black owner in the NBA. That's Michael Jordan. You have 6 black general managers, 7 black head coaches. And anybody want to guess how big that red bar is going to end up being? Just like DuBois' own diagram, this one goes off the page as well, because there are over 400 black NBA players. When you see something like this, you start to understand why NBA players are talking about ownership over their own enterprises. Like Baron Davis talking about being in talks to buy Reebok, or LeBron James owning a WNBA team. We've decoded the key rules and design choices, and for me, the most important thing was the blend of hierarchy combined with the lead up to the outsized quantity here that tries to draw your attention to who is essentially the working class of the NBA versus the ownership class and the leadership class of the NBA, and just how stark the demographic shifts are from one rung up to the next. Many of the same socio-political challenges that DuBois faced in his day are still prevalent today. They're just wrapped up and packaged a little bit differently, but they're still ever present, even in sports, which ironically many of us turn to as an escape from such problems. And so while we took a look at how even the simplest of graphical forms can tell profound stories and deal with and tackle profound socio-political and socioeconomic questions, we're now going to move from simplicity into depth. Analytical depth, that's the final category here. And if you can tell from the back of this, and given the teaser from the title of this talk, I wasn't just going to let you hanging. I can guarantee that much. There's no better graphic to turn to when we talk about analytical depth and moving from simplicity to complexity, like Minard. So here it is in all its glory, what some people call the most profound piece of data visualization ever created. The layering of data points and information here is just absolutely incredible. You've got geographic, quantitative, temporal, measured data elements. Minard had this thing for sort of combinations and maps and flow diagrams that's really popular nowadays. We see them all the time with Sankey's. And yet this was back in 1869. Minard was this kind of cartographic pioneer. One of my favorite things, again here, is how well annotated this graphic is. And something that we've noticed as a bit of a through line from the other pieces that we dove into as well, there's a little bit of admitted imprecision here. If you look at this area of the graph, 10,000 versus 422,000, you might be able to guess that that's a massive difference, right? That's almost 42x. And so that size of that black bar, which is representing the retreat of Napoleon soldiers, is not 42 times smaller than the size of that blonde, I would call it light gold bar, which is how many soldiers Napoleon started with when beginning his march towards Russia. But there is a little bit of admitted imprecision here, not just in the tracking of quantities, but also the geographic anchoring in order to make the graph a little bit visually easier to digest and read. It doesn't change any of the points. In fact, in some ways, it drives the point home even more. So, again, sidebar, when did we become so stodgy about rules? When did we decide that cutthroat precision is what mattered more than sending a clear message and telling a clear story with an emphasis on the most important and critical data elements. And so we see here this contrast of starting point, endpoint, the color contrast that emphasize the march into Russia and the subsequent retreat. We also got the branching of troops, which adds another awesome layer here, where Minard is showing where Napoleon's troops split up and gained new forces. In this case, his 422,000 was reduced into 400,000 when some troops branched off right before Wilna. Then we've got the geographic anchoring here, the rivers, the cities. We're going to move to then, if Minard had stopped there with geographic anchoring of data point on the troops, that would have been a profound enough piece of data visualization on its own. But he took it a step further and drew in this line graph at the bottom that creates an implied correlation to imply causation between temperature and weather events and Napoleon's retreat out of Moscow. What he's showing here, if translated, is he's basically saying that it was raining beginning the retreat out of Moscow. And so when you combine, it doesn't take a scientist to see that the temperature is gradually decreasing as the troops are dwindling and moving back out of Moscow. And so when you combine the idea of weather events causing this increased fragility for the troops, the weather events plus our knowledge of the guerrilla warfare and the suffocation of resources and food towards his army, it's no wonder that putting all the pieces together, some people actually think of this as Minard's display of an anti-war sentiment. And what is basketball if not a war of attrition? And so we're going to take Minard's piece on war here and do something a little bit more creative with it, which is we're going to apply this to the analysis of momentum in an NBA playoff game. Specifically, the 2013 NBA Finals Game 6 between the San Antonio Spurs and the Miami Heat. We're going to look at the successive shifts in win probability from the perspective of the San Antonio Spurs, starting with 5 minutes to go in regulation into overtime, which is the yellow bar, and then from the start of overtime to the end of the game, which is the black bar. And we're going to snake around it in the same way that Minard did his own original. We're going to level this up, curve it around, just to set it a little bit more similarly to the geographic anchoring, even though we don't have true geographic points here. We're going to infer some based on the details of the game. Once we've got these bars set up, the width of the bars represents the length of time, and the thickness, the height of the bars, represents the win probability. So you can see from the perspective of the Spurs, at the beginning, their win probability was not super high, but towards the end of regulation, moving towards the Ray Allen Dagger 3, which was really one of the plays of the series, I should say, and turned around the entire series, their win probability became super high, and then after that, they basically just never recovered and were never able to get control of the game. And you can see that when we add our graphical layer at the bottom that connects the score differential in overtime from the perspective of the Spurs to the shifts in win probability in overtime. You can see with each scoring event how, as they progress towards the end of the game, the Spurs eventually let the game slip away from them. Ironically, or I should say incidentally, the Ray Allen 3 was the turning point of the game, sending it to overtime, and it was also Ray Allen free throws that sealed the deal at the end. So what I've been telling you here, we're going to start marking them up. We annotated the time markers to the score differential graph, and now we're going to start marking up our quote-unquote geographical features. Each city or site of battle is a key play event that happened in this game. We've annotated the win probability bars or segments with the actual win probability they represent. So you can actually tie to what was the exact number. The rivers here represent important time stoppages or passages of time. So we have things like jump balls or the start of overtime. We're also, similar to the branching of troops, we're going to use that same branching idea to display the key substitutions in the game. So you can see in regulation, we're showing the Spurs, Boris Diaw exiting the game for Danny Green, and Tim Duncan exiting the game right before the Ray Allen 3. The reason that's so important for folks who might remember this game, Tim Duncan exited, and that was when the Heat actually secured an offensive rebound upon which they were able to throw the ball back out to Ray Allen, who hit the 3. And so it's an ever-growing discussion to this day, if Tim Duncan had been in the game, would Chris Bosh have been able to secure that rebound in the first place to be able to kick it out to Ray Allen to send that game? Because y'all should know, if you did not know this already, that Ray Allen 3 didn't just change the outcome of this game, it changed the outcome of the entire series. The Heat actually went on to win in 2013. So we've taken that, we've fully annotated this graph, we've gone ahead and refined our branches, refined our diagram. We've layered on, in the same way that Minard layered on geographic, data, quantitative, measured elements, we've layered on key ideas that tell the entire story of this game, from the win probability to the score line to key timeouts, substitutions, play-by-play events. In this entire package, you've got the narrative of one of the most well-played series and a microcosm of that series in one of the most important finals games and iconic plays in NBA history. With that said, there's a few key learnings that I take away from this entire thing. Now that we've gone through 3 key ways that historical data visualization can be recontextualized to tell a modern story. Number 1 is finding our own voice as graphical storytellers. Number 2 is developing a better visual vocabulary and context for modern phenomena. Number 3, obviously, this is historical data visualization after all, is just developing a better appreciation for history. And number 4, I touched on this a little bit before when talking about the admitted imprecision in some of these graphs, moving beyond a rigid set of rules. And in many ways, the first point ties into the last point. This is how I was able to develop my own data visualization skills, was looking to the past for inspiration. The way certain historical moments in sports never leave our fandom, certain pieces of historical data visualization are timeless, adaptable to any era, and they push the boundaries of what data visualization can be and can mean. So when both fields intersect, for someone like me, to whom sports are not only a source of entertainment, but also education, DuBois spirals can suddenly become a vessel for a study of African American hiring into leadership positions within the NBA, and Minard's map of Napoleon's march, a means of analyzing momentum in an overtime playoff game. So what's next for this project? I actually think that given the reception here and what I've learned and studied throughout over the last couple of years, I'm actually pretty excited about seeing the potential in turning this into a book, into a print-heavy project. If you want to find out more, you can go to spottingupminard.com, enter your email, and be added to a mailing list so you can keep up to date with the status of this project. I'm actually really excited to see where this can go. It originally started as just something where I was going to learn a little bit about a Python package, and I'm so encouraged to see the reception and how it's developed into something so much larger, something where we can come together in this community of learning and take what we see in history's best data visualization and history's most prominent data visualization practitioners, take their learnings and apply that and use it to learn more about the world that we're currently in. So a little bit of thank yous before we close this off. Elijah Meeks for honestly being the lead advisor on this project. Megan Dwyer, who actually drew the chronographer that you see here. Mike Boy from InPredict, who provided a lot of the data feeds for this project. Brent Barry, former player in the NBA and now a front office executive with the San Antonio Spurs, who's also advised on this project, and Jason Forrest, who, as a key historian of data visualization, provided a lot of this research that served as a guide point for myself and honestly a bit of a lifeline in learning about historical data visualizations like the DuBois spirals. So if you want to follow me further, I'm available on Twitter, Instagram, LinkedIn, GitHub. On GitHub, I've actually got a series of comprehensive Python data visualization tutorials. So feel free to stay in touch. Feel free to connect. Go to spottingupminard.com so you can stay up to date on the status of this project. And with that said, thank you so much, and let's open up the floor for any questions.